Howdy, IB. It's Miss Kosh. I had some questions from my HL kids on some of the binomial expansion problems. So I'm going to see how many of those I can do in this video. So first of all, I'm not exactly sure what they're asking for in number 3, unless they're just referring to this piece right here. Okay, because this is kind of the definition of, well, so we know that a plus b to the n is going to be equal to the sum as r goes from 0 to n of, well, there's the combination where we have n choose r, and then we have the a term gets raised to the r, no, I lied to you. Sorry, I didn't mean to lie to you, but I did. The b term gets raised to whatever your r value is, and then therefore the a is then n minus r. Okay, so that is what they've defined for us. Well, so the only difference between that and the problem at hand is that they now say, well, b is negative. Okay, well, so in this case, if I have a minus b to the n, then I know it's the sum as r goes from 0 to n of n choose r, and then a raised to the n minus r, and now negative b raised to the r. And so what happens here is that we still have this. But we have this is a -1 that's raised to the r, and then a b that's raised to the r. And so then they just reordered that, and that's, I don't know if they want any more than that. If they want more than that, I don't know what to tell you. So that makes me happy at this point. It's just being aware that that -1 is getting raised to the r, and that's what shows up here. Okay, let's look at the next question that somebody asked. They say, consider the expansion of a plus x plus b, not a, x plus b to the 7. Okay, write down the general term of the expansion. Okay, so the general term is going to say, well, I've got 7 choose r times x to the 7 minus r times b to the r. Okay, and then they say, find b given that the coefficient is that, -280. So we're going to set that equal to the coefficient of x. So we know that, well, let me not do that. Okay, so then in part B, they say we want to the x to the 4th. So what that means is we need to do 7 choose something, x needs to get raised to the 4th, which means that r is going to be 3. So that's going to be 7 minus 3 would give me 4, and then that means b is raised to the 3, and that means that this is a 3. And this has to equal a -280. Okay, so 7 choose 3. Oh, I have a calculator nearby. I go option over to probability. Yep. And then I hit, so 7 choose. I hit the wrong button. Option over to probability. There we go. 7 choose 3 is 35. This piece right here is 35. This is now x to the 4th. And this becomes b cubed is equal to -280. So 280, I'm sorry that you can't see what I'm doing, divided by 35 is a -8. And this I know to be a -2. Okay, because a -2 cubed is a negative times a negative times a negative. There's 3 of them, and so that becomes a -8. I don't know why my handwriting gets glitchy over there, but it does. Okay, so find B. We did. Yay. All right, the next question somebody had was they asked about number 11, part D, and they asked about 12, part F. I couldn't highlight it because, anyway, I just couldn't. Okay, so the coefficient of x to the 11th and the expansion. This is where I would do the little boxes and triangles. And so we have, find A. Okay, so they're telling us, so we've got 10 choose, I think I do triangles, and then I have x squared to the box, and then I have 1 over ax to the triangle. And we know from here that our box plus our triangle has to add up to 10. And we know that on this one, so here I see this becomes 2 box, and this becomes a -1. We can't see it, but this would be, you know what, hang on. This could be rewritten as 10 triangle x to the 2 box. And then this becomes 1 over a times x to the negative 1, and all of this is getting raised to the triangle. Okay, I don't always write that step, but I want to make sure that you see what's happening here. And so in this one, we have 2 boxes that came from here, that there, and then I have a negative 1 to the triangle, gives me a negative triangle. So 2 box minus triangle is equal to, well, what did we needed to equal, I forgot, x to the 11th. Okay, so those exponents need to add up to 11. So now I see I have a lovely little system. My triangles cancel. I have 3 boxes equal to 21. That is grand. If it doesn't equal an integer, you messed up somewhere because these all are going to be integers. And so box is equal to 7, which means that triangle has to be equal to 3. So to find that coefficient, oh, we need to find a. That's what we're trying to do. You know what? I'm going to get rid of this for just a second. We just said, well, okay, box is 7, delete. We just said box is 7. And triangle is 3. So it's 10 choose 3 times x squared to the 7th times 1 over ax to the 3rd. And this is going to equal 15, x to the 11. Let's see if that's correct. Okay, 10 choose 3 for my calculator is 120. This becomes x to the 14. This becomes 1 over a cubed x cubed is equal to 15 x to the 11. Sure enough, notice this and this will give me x to the 11. And so now I have 120 over a cubed is equal to 15. Okay, so 120 is equal to 15a cubed. 120 divided by 15 is equal to 8. Oh, that's glorious. That means a is equal to 2. Lovely. Okay, then there was a question on 12F. Find the constant term. Oh, lovely. Okay, let's think about this for a second. Is there an easier way to do this besides multiplying the whole mess out? That's what I'm trying to think about. Well, okay. Let's start up. We're going to have 2 little pieces here. I don't really want to expand each of those and then multiply it out. So I want to kind of outthink them. So this is 3 choose, we'll use r here, and then times x squared to the 3 minus r, and then 1 over x to the r. That becomes well, okay, hang on. What I forgot to do is I forgot that it's the sum. The first part here, it's the sum as r goes from 0 to 3 of that. Okay. So that would give me all 4 terms when I have plug in 0, 1, 2, 3. And then, is this the best way to do it? Okay, maybe I should come back in a second. Okay, then it's the sum as, let's use a different variable. I like the letter k. K goes from 0 to 4 of 4 choose k times x to the 4 minus k times negative 2 over x to the k. Sorry, my 2 problems are encroaching upon each other. You guys get to go away. Oh, nope, no, delete. Sorry, you got to watch me do that. Isn't that thrilling? Okay, so let's see. We're going to end up with, find the constant term. Okay, well, here's my hesitation. So I can't just do, this is going to have, like if I expand the first one, I'm going to have the very first term in this part right here is going to be x to the 6th. And then the next term, it's going to be plus 3 choose 1 times x squared squared times 1 over x to the 1st. And so 3 choose 1 is 3. This becomes, so it's x squared plus, and there's more coming, I haven't done it yet. This would be x to the 4th minus an x from that one. And so this gives me plus 3x cubed. I just didn't want to expand everything out because then everybody here has to multiply. You know what? I think I probably am supposed to. I'm not seeing a shortcut. currently. Okay, you know what? You go expand that out, and then I'm going to finish. There were two more questions that someone asked. They asked about number 14, and they asked about one on a worksheet. So let me I'll come back to this one after I've had a chance to think about it, and to expand it out. I don't think you want to see me do every little bit of that, because what could happen here, the constant term, we could have an x to the third times in this piece right here could be multiplied by something that's 1 over x to the third, and then those would cancel. So it's going to get kind of messy. So let me think about that again. So we'll get you started on some of this, and then I'll go back and see what I can do for you. Write down the first 5 rows. Sorry. Well, that may be 6 rows, but whatever. Okay, so this is cool. The sum of row 1. So if I come this way is just going to be 1. You know what? I need a new color. 1. This we kind of talked about. This is 2. This is 4. This is 8. This is 16, 10, 20, 32, and that's 32. And so what you'll notice here is that this is the point that they're trying to sum of the numbers in row in a Pascal's triangle it's actually, okay, so notice this is actually the 0 row. And so this is 2 to the 0 equals 1. This is 2 to the first. This is 2 squared. This is 2 cubed. This is 2 to the 4th. This is 2 to the 5th, which is why I would call this the 5th row, even though it's the 6th row technically. But isn't that cool? Okay, so show that. Oh, that's just the definition. Okay, so I'm looking at this part right here. Well, so we know that 1 plus x to the n would be equal to the sum as r goes from, from 0 to n of n choose r times 1 to the n minus r times x to the r. And then when you write that out, you end up getting what they have right there. So hence deduce. Oh. Let me think about that one for a second. Oh, I should have thought about these before I started the video. Okay, I will come back to this one also, but I definitely know what to do for this this last one that was asked about. So anyway, in a perfect world, these would be perfect. It is so far from a perfect world, it's not even funny. Okay, so this is equal to what? 2x times x times, let's see, I need the 3 to go here and the 1 to go here. This should be positive, this should be negative. 2x squared plus 3x minus 2x minus 3. Okay, yeah, that's good. So they say hence. I think the directions actually said hence or otherwise, but hence is a big clue for you in the IB world. Hence means look back. See, this was part A, this was part B, really. Look back at part A. Hence tells you that part A set you up for success. So in other words, what we want to do is we want to say, well, this is 2x plus 3 times x minus 1, and all of that is raised to the 8th power. Okay, I'm going to cough again. Hang on, let me drink some water. In a perfect world, I'd edit this video. In a perfect world, they'd pay me more. So, you know, it is what it is. Okay, so this, I'm kidding and not kidding. This is now that, okay, since each of those are raised to that power. So they want us to find... Well, this is a real winner of a video. Okay, so they want us to find the term that has x. So there's two things that we need to consider. We have this first part here. We'll expand out. It'll have all these terms, and then it'll have some term here. It'll say plus, and then we'll have something with an x, and then we'll have something that's a constant. And then the next one will do the same thing. It'll have all this stuff at the beginning, and then it'll have something with x, and then something with a constant. And so we're going to find our final answer by taking the term in x multiplied by the constant in that other one, and this times this, and that's the only way that you can get something with x. Okay, so think about this for just a second. Notice if I had like x squared plus x plus 1 times 2x squared plus 3x plus 4, just to change this up. The only way that I can get an x term, well, if I expand it out, I have 2x to the fourth plus 3x cubed plus 4x squared. I just multiplied this guy by everybody in the other one. And then I have multiplied this by everybody. Then I have 2x cubed plus 3x squared plus 4x. Notice how I'm lining things up. Then I multiply that, and I get this exact thing that I started with. Okay, so if they're saying find the coefficient in x, that's this right here. Well, how did I get this? I said this term times that, and then I also said this term times that. That became this value right here. Okay, and so that's what we're doing, but on a grander scale. Okay, so that's kind of the rationale behind this one. And so you have to expand out the first one and figure out what your x term is and your constant, and then find the x term and the constant in the other one, and multiply the x term times constant, and then add the x term times the constant from the other scenario. Does that make sense? Do you know what? I will start my next video with the answer to this one, and I'm going to think about the other two. So, all right, enjoy. I'll see you in a bit.